Okay, another mixed rule problem. So when I look at this, I can describe the whole thing as inside and outside. So I'm going to start with the chain rule. I've got an inside of the e to the 2x over cotangent 4x plus 6 and an outside of an exponent of 4. So I'm going to start with the chain rule. So starting with the chain rule, multiply by that exponent, leave the inside completely alone, decrease the exponent by 1, then times the derivative of the inside. Derivative outside, derivative inside. And now we just keep working away at it. So the derivative outside, I'm done with that, so just leave that alone. Derivative of the inside, a quotient rule. Plain denominator. Derivative of the numerator minus plain numerator, derivative of the denominator. I need to write smaller, otherwise I'm not going to get it on this line. So let's try again. And if I was really good at videos and stuff, I'd edit all this out, but yeah, I'm not good at that. You're lucky that I know how to turn on the document camera. Okay, so going with my quotient rule again. I'm going to give myself more room here, too. Derivative out. Derivative in. Okay, so let's start with that quotient rule again. Plain denominator. Derivative of the numerator minus plain numerator, derivative of the denominator, all over plain denominator squared. Quotient rule. Plain denominator, derivative numerator, plain numerator, derivative denominator, plain denominator squared. And you wouldn't have to show this step again. That's just my attempt to get everybody to learn the quotient rule. So let's take those derivatives now. So 4e to the 2x over cotangent 4x plus 6, quantity cubed. Plain denominator, so we won't do a thing. Cotangent 4x plus 6. Then I get to the e, and so we remember our words, that it repeats derivative of the exponent. Repeats derivative exponent. So plain denominator didn't do anything. I get to the e, the words for e repeats derivative of the exponent, up to the minus sign. Then my derivatives again. Cotangent, the effect of that 4 is to multiply by it. So 4, and then cotangent, the derivative of the cotangent is negative cosecant squared. The angle doesn't change, and the derivative of that 6 is 0. All over cotangent 4x plus 6 quantity squared. And there's my unsimplified derivative. Now at this point I always have people panicking. How many of these are going to be on the test? How many of these are going to be on the quiz? If I put a long problem like this on a test or quiz, there'd only be one really long problem. And the way then the points are distributed, the vast majority of the points go for the calculus. So if this were, say this were a 10-point problem. Yeah, I don't know how many points it'd be worth, but say it was a 10-point problem. At least 7 of the points would be for the calculus. You are not going to fail the course by not being able to simplify. But if you can't simplify anything, you certainly don't deserve probably an A or a B. Algebra and trigonometry, those skills are prerequisites, and if you don't have those skills and still don't have them by the end of the semester, an A or a B is a grade that you don't deserve. The algebra and the trig probably will not be the difference unless you totally don't know algebra or trig. If you totally don't know algebra or trig, you're going to have a hard time with the class. But if those are weak skills, you can still get a C in the class, but you probably aren't going to get an A or B if your algebra and trig are really weak, are somewhat weak. If they're really weak, you are going to struggle. If they're somewhat weak, you probably are not going to get an A or B. But anyway, if this were on a test or quiz, there'd only be one problem like this, and the vast majority of the points would come from the calculus. But now, simplifying. So let's just do a little bit of easy stuff. First of all, remember these guys can't cancel. We're not going to look at this right now. Nothing cancels in here yet because you can't cancel a fraction unless everybody has that. So everybody has, I didn't explain that well. You can't cancel these unless everybody has the cotangent 4x plus 6. So just doing a little tiny bit of simplification. First, I'm just going to do a little rewriting. I have an e to the 2x and a 2, and I'm just going to bring those forward because they'll look prettier there. And here I've got 2 negative signs, so that's going to make it plus, and then I'll bring that 4 to the front. Then factoring from here, you've got lots of options here of things you could do. And what I notice here, factoring, 4 and 2, I can factor out a 2. E to the 2x, I can factor out an e to the 2x. And so 4, e to the 2x is leaving this guy alone up here. So in this numerator, I can factor out a 2 and an e to the 2x. So from here, factoring out 2 from the 4 and the 2, e to the 2x. So factoring that out, so I factored out the 2 e to the 2x, which will leave me a cotangent 4x plus 6. And then I factored out the 2, so 4 divided by 2 is 2. Then I have the cosecant squared 4x. And I'm going to put all my little arguments, I should have done this earlier, put all my 4x arguments in parentheses. It'll be prettier that way, and I apologize that I didn't do that sooner. So all I did there was just put all my little 4x's in parentheses because it's just a little prettier and easier to understand that way. And if I wasn't lazy, I'd go back and redo this whole video, but fundamentally, like most people, a little bit lazy. Put that 4x around there. Put 4x around there. Okay, so all I did on this first step essentially was factor out, since both these terms up here on either side of the plus sign, since they both have 4 and 2, both have a factor of 2, I factored out a 2, and they both have an e to the 2x, I factored that out. So 2 e to the 2x, then that left behind the cotangent 4x plus 6, then I factored out a 2, 4 divided by 2 is 2, factored out the e to the 2x, leaving behind the cosecant. Just a little bit more simplification. And so I could be very, very explicit here. Now I could even take that e to the 2e to the 2x and make it its own fraction. I could do that. It wouldn't be wrong to do that. Then I could do this. That this is 4 times 1, 4 out in front. And then that'd be e to the 2x cubed over cotangent 4x plus 6 cubed. That instead of just having one fraction cubed, I can cube the numerator and denominator separately. And then 2e to the 2x over 1 times cotangent 4x plus 6 plus 2 cosecant squared 4x all over cotangent 4x plus 6 quantity squared. I'm going to zoom out just a little bit so you see that once. Okay, take it another step. Exponents to exponents, we multiply. So that's e to the 6x over cotangent 4x plus 6, quantity cubed, times 2e to the 2x over 1, times cotangent 4x plus 6 plus 2 cosecant squared 4x, all over cotangent 4x plus 6, quantity squared. Okay, and we are almost here. 4 times 2 for 8. Right? 4 times 2, 8. E to the 6x times e to the 2x would be e to the 8x. And so where that came from, e to the 6x times e to the 2x is e to the 6x plus 2x. Then I still have the cotangent 4x plus 6 plus 2 cosecant squared 4x. So that was everything that was in the numerator. The 4 times the 2 for 8. The e to the 6x times e to the 2x gave me the e to the 8x. Then everything else in the numerator. And then in the denominator I have 1 times 1, which I certainly don't need. But then I have cotangent 4x plus 6 cubed times cotangent 4x plus 6 quantity squared for cotangent 4x plus 6 quantity to the 5th. Cubed, squared, 5th. Add the exponents. Now there is absolutely as much as you could do to simplify it. And honestly, no, got it. There was a flash there. Hopefully everything's still okay with the video. Honestly, no. I would never put a problem like this on a test or quiz. But in class, we need to do things harder than what you're going to experience routinely, because that's the only way you get good at stuff is to practice hard things. So in homework, might I do this? Yes. On a test or quiz, no. And this also gave me an opportunity to review all sorts of good algebra with you. But that's the end of this video.